And we are back live. Welcome back, everyone. If you're just tuning in, welcome to API or GraphQL Scale. So we are going to move into our next talks. I hope everyone had a chance to grab a beverage, grab some time in the networking booths. If you didn't, we will have another one of those in about an hour and a half. So feel free to check those out at that point as well. But next up, we have Michail Staib joining us from the GraphQL Technical Steering Committee to talk about what's next for GraphQL. And I assume we're going to hear about that, but I'm looking forward to hearing what's next from the steering committee.
Yeah, hi there. I'm Michail Staib. I'm a GraphQL TC, but I'm also the founder of Chili Cream, and that is essentially responsible for the .NET implementation of the GraphQL server. So I want to talk a bit about this next about GraphQL, and the general thinking about GraphQL is that it has a bit stabilized. So when people ask, is there coming anything new? Because the last spec version essentially was an introduction of repeatable directives, but nothing really special like subscriptions, for instance. There, you could say, in the transition from GraphQL becoming the property of the GraphQL Foundation, moving away from Facebook and really being developed within a working group, there was a bit of transition phase, which took us some time. But now we can see like huge new features that are moving into GraphQL. And I want to shine a bit light on them, like the very next features where I think they will make it in the next spec cut. It's not promised. But I also add features that might be further into the futures. So let's dive into that and see what's next for GraphQL. So the predominantly new feature that I think will make it into the next spec cut, and a lot of us are really working hard to get it right. Rob Richardson is having the lead on this, so he's doing a lot of work on stream and defer. So what is stream and defer about? So when we look at GraphQL traditionally, GraphQL was introduced by Facebook to solve a certain need for native mobile applications for Facebook. And it was mainly to reduce the calls, the network calls that they had with their backend to have a more efficient way to communicate, right? But that also means that as we put more and more in our network cores, have larger network cores with GraphQL, that our data really is waiting for the slowest component that we are asking data from. So if I have one very slow field, one very slow resolver, that really slows down my network call. So stream and defer are about minimizing the time for important data. Give me the tools to prioritize, and then we can stream down the data and give you the important things first. So let me show you a bit an application here, and that is just refresh it. It's a Lambda, so it needs to start up the first time. So when I look at this application, it has a good load time, but and a lot of data that you can see here, like this ticker data, some lists and stuff. But really, it's just one GraphQL call. And if I look closer at this data, you can see that I can see here the Bitcoin graph. So don't buy or sell any Bitcoins yet. The prices here are fake. So not that you try to get the good price here. But if I want to dive into my data here, I can look at the Bitcoin or slide to the side and look at other graphs. So what stream and defer is about is that I am able to define what data I really need for the user to see, so my web page loads very fast. In this instance, I want the Bitcoin data, but I could skip the ADA data, or I could skip the algo data for my first bits of data. So I want to be able to tell my GraphQL server, give me everything that the user sees immediately, and then you can stream slowly the rest of the data down. Okay, so let's have a look at how that works. And I have here Banana Kickpop, And that is our GraphQL ID. And I prepared already here the query. That's essentially the query we see that is being executed when I am on this website there. So I'm fetching here the assets and then the price and a lot of other informations for my graph. And if I run that query, you can see it takes a bit, almost 2 seconds, because this data section, I know that because I programmed it specifically for this demo, is very slow. It uses a downstream service to fetch these price data. And I'm fetching also all of the data. So I have the Bitcoin and all the others in the first call. So in order to stream that, I can now add the stream directive here. And with the stream directive, I can, for instance, say that we want the first item first. We want the Bitcoin first. But then the data, the rest of the data can trickle in as it is ready. And you can already see, oh no, that was wrong because this is not the list. And this is our list. The nodes here are streamable, so I can only stream lists. So let me rerun that. But you can already see that our request time reduced dramatically from 2 seconds to 340 milliseconds. And what is happening is that we have a single HTTP post call and the data is being streamed now. You can see I have a lot of data patches. So first I get the Bitcoin with all its data. And then I get other, like the ADA, for instance, or the Matic and other coins that I want to have. They are streamed then in patches. And we do that by using something called a multi-part response, where each part represents a single patch for our system. Okay, but we could do more, because stream is one thing. There's another thing that we call defer. And defer, I can mark sections that are not so important for me for the first bits of data. So I can mark here an inline fragment or fragment, for instance, and say defer this section. Let's do that. Reformat that. And then this is also now being patched. So let me rerun that. And you can see the first bits. Okay, that was actually slower. I'm on a mobile connection, but you can see now it's around 200 milliseconds. So I'm shaving off a couple more bytes, a couple more milliseconds here. And if I go into my logs, I actually can see that we have it now even more patches, now 20 patches. And if I drove into that, you can see now I get the ADA, for instance, in a second patch that's from the list is being streamed. And later on, when this slow rest service has the data ready, we can see that we get data patches through that. So that is great. And now I have one of the problems reduced. I can now do this one GraphQL call, and then data is being prioritized in the first patch. So I get the immediate data first, and then later as I complete, I get the other data. And this is great if you work with suspense in React, for instance, and things like that. But so Lee Byron introduced this feature as an idea to us already in 2016. Why did it take so long for us to have it now running in servers here and working, but still it's draft at the moment? And that's because there are a lot of problems we have to solve around that. For instance, this is the same query, but more componentized here. And what easily can happen is if we look at components, at our data components, fragments that might be embedded in one of our relay components or whatever client you're using. And suddenly we think maybe we want to optimize this call here. Let's, for instance, add here a stream to this lower section. And you can see I have here a stream that the defer is essentially the same query as before, but now I added just one more attribute into this, and we are running that. And you can see already my UI is kind of freezing here. And if I go to the logs, you can see that suddenly just I added one directive and suddenly I have 3,000 patches, which is now the opposite of optimization. So just by adding a lower level nested stream directive, I kind of destroyed my performance gains I had before. So this is one of the things we are at the moment discussing around this feature, how to solve these things, and just to get you a bit of an idea why some features take a bit longer. So what we are looking at the moment is how the GraphQL engine could optimize that, could get rid of this lower level stream to make it fast again, optimize essentially the query for us. And there are a couple of discussion points around that, how to do that. And that leads me also into the next feature we will be seeing, and that is called fragment modularity. And they are actually closely related to each other because I explained fragments are kind of our components. And when we think about GraphQL traditionally, then the main focus of GraphQL was to optimize network requests, minimize network responses. And there is one of the most complex algorithms in GraphQL is actually the field merging algorithm. So the first thing we do when we get a GraphQL query into our GraphQL engine is decomponentize the query, so defragmentize. That means the first thing is we rip out the fields in a fragment and then we smash it into the main query. So at the end, we don't have any fragments left in our query. But this now has some problems with defer and stream, because for us the fragments are actually the data contracts for our components, and we do that because we want to collocate the data requirements of our component with our component code. But if we think about it and look at the fragments I executed in my query earlier, we have something called here asset info and price details. So if my engine now got rid of some of the defer directives here, maybe turned this defer from true to false, we couldn't identify anymore, is this fragment already delivered for my component? So the client application has kind of a difficulty around identifying if some piece of data it needs for its data contract to work this component, is it already delivered? Can I display the component? And what we essentially want to do, and that is the main goal around fragment modularity, is then we want to reason about fragments in isolation. That means we want to kind of be able to maybe await the fragment, have our asset maybe as an object, and then be able to refer to our fragment as another operation in our asset maybe. Or we want to maybe test our asset, does the property price details exist on it? Can I render or do something with the data? And there are a couple of approaches how we could do that. And that one is maybe introducing metadata to our model, like an is-fulfilled constant in the GraphQL engine, where we then could use aliasing to identify if fragments are there or not. The main issue with such an approach is that it kind of you kind of have now different structures in your client code than your query looks like. At the moment, we have a one-to-one relationship in most clients, but now you would start having different structures. So there are also other approaches to that, and that is kind of aliasing our fragments. And this would then create a new response shape, if we think about it, where we essentially push down the fragment properties one level deeper. But as I said, before GraphQL was very much optimized on efficient network responses, but this would kind of duplicate now properties in some cases where maybe we have overlapping fields here, and because we alias the fragment, we would have them now multiple times. And maybe this shows you already a bit that it's about compromises that we try to do. So if you already are experimenting with fragments and defer and stream with all the new stuff, it is available with GraphQL.js in some preview builds. You can use the newest version of Hot Chocolate, the .NET GraphQL server, and run that. This is actually running on Hot Chocolate. And if you want to work around this fragment modularity concept, you already could introduce here kind of a hack. So I could say maybe it's price change fulfilled, and then misuse our type name here. And then you get essentially the same indicator if something is there. That's actually what we do in our .NET implementation here. Okay, so let's move on a bit to another concept or another feature we are reasoning about in the workgroup, and that is client-controlled nullability. So what is client-controlled nullability? And I get at the beginning it's hard to grasp. So this feature actually was pushed in the beginning by Yelp, or a couple of employees by Yelp. And they had a problem in their client application that many fields in GraphQL are nullable. And we are doing that because there is something called the non-null propagation in GraphQL, where if you cannot fulfill a field, something happens in your resolver, you have an error, then the field is nulled by the GraphQL engine. And then if the field is non-nullable, we would propagate this non-null error and erase your result until we have a consistent result again. That is actually one of the things that makes GraphQL so predictable. But it is like annoying when you write client applications because you have to write null checks for fields that might never be null, just if there's an error. So with client-controlled nullability, we give now the power to the consumer to specify which parts are not null. Essentially, introduce error boundaries to your GraphQL requests. So let's have a look at how this looks like. So this is a simple GraphQL query, and you can see we have a couple of fields here. And actually, this white paper field is nullable, but in most cases, we have a white paper. There's just one case where we don't have it. And our component might just expect a case where it's not null. So what I can do now is essentially say that this field is for me non-nullable. And then the GraphQL engine will take that into account and apply now this non-nullability. And we, in this case, get an error here. And you can see all the data is erased because that is not nullable anymore. And then we are erasing essentially this selection set here. So but with non-null client-controlled nullability, I can now dig in here and rewrite the nullability, for instance, for node here, and say, actually, we capture this here. That's my error boundary now. This outer thing is non-nullable, but we are capturing the error in here. And now I get like a consistent result. We have my data here, and only the piece that violates my client contract that I defined now is being nulled out, and I can filter that then out in my client components. Okay, so these are some big ticket features I think will change really how you work with GraphQL, especially defer and stream will make it so much more efficient to work with GraphQL. But there's a ton of other stuff coming. Like we have structs, it's a new type we are talking about. It is not guaranteed there's these things coming, but just to show you on what the GraphQL working group is working on or discussing. There's a metadata, and that is a really a feature that many people want to have, like like that the introspection is able to look at annotations that we have with directives or other constructs. It is not possible today, but there is work going on to make that possible. We have things like one-off, that is input polymorphism, things like feature flags that we want to use to inform people that maybe this is a proposed thing in your graph, and you can then filter these things out. So there's a lot of things coming. So the main message you should take away is GraphQL is developing rapidly, and there is a ton of new stuff coming. And we actually now have 3 workgroup meetings, like almost every week we are getting together, discussing it. And if you are located in Australia, we have now also a workgroup meeting in the Australian time. So I encourage you, if you want to take part in these spec discussions, to join in or just to listen in. And with that, I'm done. And if you have questions, please shoot.
All right. Well, as we wait for questions, that actually brought up a very important question for me. So you've got the working group meetings that are happening. Are there other places that people can provide feedback on these proposals?
Yes, sure. So all these proposals are actually discussed on the spec repo. The defer and stream repository, we have a specific repository around that, but you can find that on the spec issue because it's a very complex feature. I would say it's the biggest feature since subscription that is being introduced into the GraphQL engine. You can see now you can stream data, you can defer sections of your graph. So it will completely change, I think, the way we work with GraphQL.
And I have to say, just like listening to that part of the presentation, I'm very glad that I don't have to think through those things. I'd much rather consume those things, but I do appreciate all the work that goes into making sure that it's stable as it kind of goes forward. So definitely appreciate that. I got a question from Alex. How do you approach general developer education about these new features, in addition to the official spec and the GraphQL Scale conference, of course?
Yeah, I mean, we're doing a lot of talks. I'm speaking about at other conferences about this, and I'm not the only person working on that. There is Rob Richards, who is the main guy pushing at this specific spec item. So there's a lot of these GraphQL TSCs that go out there and preach about the features. And there is now Apollo is buying into this feature, and they are also pushing it on all their products at the moment.
Totally. Cool. And then I kind of had something around like the client-controlled nullability, but it's more of a philosophical piece. So with the working group, how do you balance the client needs with the goals of predictability and all the back-end needs? Because I love the idea of the controlled nullability. I want to control my nullability, but obviously that might be against some of the early philosophies of things.
Yeah, actually, it's. I would say that it's very much in line with this, the philosophy of GraphQL, where we give you control over it, but it's very predictable how that works. So the nullability, you could see how it errors out. It's still the same algorithms that work on that. But I would say, like the defer feature, for instance, has a lot of things where we have to balance things out, because in the beginning we had quite a lot of very long discussions around that we must honor the deferred directives that the client really defines. But then as we pushed these things to experimental servers, we could see that if we give the full control of that to the client, you could really kill your server performance. So there is a lot of balancing where you have to do and say, okay, the client, what does the client really want? The client actually wants to have very fast streamlined queries. So if we can better figure out how to make them fast, it's okay to skip one of the different differs and streams. But there is this is an ongoing discussion to balance really these needs. And you have client framework developers in the user group as well as server developers. And that's why it's so balanced, because we take both perspectives.
Perfect. And then real quick, since we got one more minute, we got one more question. Jaren from the audience is asking, with error boundaries, if the parent wouldn't cause issues in terms of validations when the parent is non-nullable and the child is null?
You can override that on every level, so it depends. You could create, like when I first introduced this first question mark, you could see that it almost errored through all the types up. So you could create constructs where you essentially lead to all your results being deleted because you didn't pay attention. But this is something you can put analyzers on that, and you can try it out first, how this really happens with your queries. So it's very controllable.
Amazing. All right. Well, that's it for the questions that I've got currently. Michail, thank you so much for sharing what's coming and walking us through all of that. Thanks so much.